Welcome to Class PM. Odisha was hit by a cyclone on 18th October 1996 with a wind speed of 200 kilometers per hour. Because of this cyclone, there were 45,000 houses smashed and more than 7 lakh people made homeless. And in the same year, on 20th October, the cyclone again repeated in the same place, and which has left many of the people again homeless who have lost their lives. There were crores of rupees damage. A damage of crores of rupees was caused. There was a damage caused to communication, at the same time roads, railways and many other things, right? So this has left none. The cyclones do not leave anyone. They don't have mercy. They just clean away or flush away the things which come in the way, right? So there are many cyclones you might have heard about. Now you might be thinking, like, why am I talking about a weather report? Why am I giving a weather report? Am I going to practice this news to read it out in a news channel? No. We are going to learn about wind, storms and cyclones this lesson. We know that these cyclones are very destructive. Now, why are these cyclones so destructive? What is the cause for the cyclone? How are they caused? Let us learn about all these things and let us know the information about this. And before we know what are cyclones, or we know how the cyclones are caused or how do they occur, let us learn some basic information which is related to the cyclones. Like, we have to talk about air, which is one of the important thing which will cause cyclones. Now, let us begin this lesson with a small activity to understand what happens during cyclones. And the first activity what you are going to learn is to prove air exerts pressure. We are going to have an activity to prove air exerts pressure. Air exerts pressure. Now let us learn some basic information how this air is one of the important component which causes cyclone. So let us begin this lesson with activities which will tell us about air and its role in cyclones. So first let us start with an activity to prove air exerts pressure. To prove that air exerts pressure. Now when we talk about air exerts pressure, I'll tell you an activity. For this activity, you need only simple things like metal can, a tin can, okay, or a plastic bottle. A tin can or a plastic bottle. Take a tin can, fill the tin can half approximately with water. Now take this tin can and place it over a candle and lit the candle. Let the water inside the can start boiling. And once the water starts boiling, put off the candle and cover the lid of the tin can carefully. Please ensure that you handle this tin cans carefully, because as the water starts boiling, the heat is being transferred to the tin can also. So it will burn your hands. See, ensure that you will close the lid of the tin can properly without hurting yourself. Now after you close it, take this tin can and place it under a wash basin and run down fresh water. Now what do you observe? You observe that the shape of the tin can deforms or it gets distorted. What do you mean by deforms? Deforms in the sense, see, you know the container shape, right? You know the container shape. It is crumpled, it gets deformed. The shape of the tin can changes. If you have no tin can at home, you can repeat the same experiment using a plastic water bottle. Take a plastic water bottle, fill the plastic water bottle with hot water and close the lid of the water bottle. And now remove the water immediately, empty the bottle immediately and close the cap again and place this water bottle under running water tap. You see that immediately the shape of this plastic bottle gets deformed. Now what does this indicate? This indicates that air exerts pressure. This indicates that air exerts pressure. Now how do you know like air has exerted a pressure due to which the can or a plastic bottle has deformed? Can or a plastic bottle has deformed. Now we know that the shape gets distorted. The shape of the can is distorted or deformed. Now how do you know that the shape is distorted, or how do you explain that air exerts pressure? Now when you take this can and pour water over the can, the steam which is present inside the can condenses down to form water and the level of the air gets reduced. So due to which we know that the can gets distorted. Now, how does the can gets distorted? How does the air acting on it, or the air pressure acting on it, can change the shape of the can? So, when you pour water over the tin can, what happens? The steam which is present inside the tin can gets condensed. condense and it will occupy the space. It will occupy the space of the air, and that will make the pressure of air lower inside the tin can than the pressure of air which is outside the tin can, due to which you see the shape of the tin can gets compressed. The shape of the tin can gets compressed. The same way, when you take a plastic water bottle, fill it with hot water, empty the water and close the tap of it, and when you put it immediately under a running water, that is tap water, when you just put it under running water, you see that the shape immediately gets deformed, because when you empty the water, there is few steam left inside, right? When you are condensing down, pouring water over the plastic bottle, the steam occupies the space of air inside. The steam occupies the space. See, assume if this is the tin can, when you empty the tin can and pour water over the surface of the tin can, the steam which is present at the sides of the container will condense down to form droplets of water, right? So that means they have occupied the space of air which is present inside. Now the space of air which is present inside is reduced, whereas the air which is present outside is more. Okay, the pressure of air from the outside is higher than the pressure of air inside. So that is the reason you see that the shape of the can gets deformed. So this simple activity tells us that air exerts pressure. Now I have few examples, like can you fly your kite without air, or will you be able to ride your bicycle along with in opposite direction of the wind currents, right? So you cannot do all these things. So this tells us that air exerts pressure. We have seen that high wind speeds are accompanied by reduced air pressure. Now what if there is a high wind speed all over the roof of the ceiling? I think if the ceiling is light, it would be lifted and blown away, right? So we already know that moving air is called as wind. So we have seen that increased speed winds can reduce or accompanied by reduced air pressures. Now let us see how this air could be destructive. We know that the wind is nothing but the moving air is called as wind. So this air always moves from the region of a high pressure area to a low pressure area. The greater the difference in the pressure, the faster would be the air moving. We have seen many activities to prove that high wind speed are accompanied always by reduced air pressures. We know that air can be destructive. It can cause cyclones. It can cause storms, right? So we know that always air moves from a area which has high pressure to an area which has low pressure. Now the greater the difference between these pressures, the faster the air moves. Now how are these differences created in the nature? Temperature is also one of the component which can cause these differences. Now let us learn about all this in detail by doing a small activity which can tell us that air expands on heating. Air expands on heating. Let us do a small activity to see how air expands on heating and how is the differences between these can cause disturbances in the nature, right? Let's do a small activity to explain that air expands on heating. For this you need a beaker, water, a boiling tube and balloon, right? Take two beakers, mark one of the beaker as A and mark one of the beaker as B. In one of the beaker you take hot water, okay, and before you take hot water you have to tie the mouth of the balloon, mouth of the boiling tube with a balloon, right? And you can use tape so that you can fix the balloon tightly. Now immerse this boiling tube into this beaker of water which has hot water and leave this arrangement for 2 to 3 minutes and observe what happens. Now take another beaker, fill it with cold water. The same thing, you can have the balloon tied over this mouth of the boiling tube and immerse this boiling tube into the water and leave this for 2 to 3 minutes and observe what happens. You see that the balloon which is fixed, or the boiling tube which has a balloon immersed into the hot water, shows inflation. The balloon inflates here. The balloon gets inflated. The balloon gets inflated, whereas this is deflated. It doesn't inflate. It doesn't blow, right? So why is this balloon inflated? No, as we know that this hot water rises up, which takes in air from the surroundings and condenses down, which will make the pressure of air reduced, and then you see that the balloon gets inflated. But whereas in case of cold water, there is no vapor which rises up. See, when water is hot, definitely the water hot water rises up, which will inflate the balloon. But whereas in case of the beaker B, there is only cold water, and this cold water, it doesn't move, right? It doesn't rise. So there is no inflation seen in case of beaker B. Instead, it is only deflated. So this small activity explains us that air expands on heating. Air expands on heating. We have been discussing about how air expands on heating. We have seen an experiment to show how air expands. Now let us do one more activity to understand better that air expands on heating. And at the same time, we know that we have discussed in the previous activity, due to the hot air which rises up will inflate the balloon. In the same way, we'll see another activity which will also help us to understand how air expands on heating. For this, you need to take 2 paper cups or paper bags. Take 2 paper cups. Tie these paper cups to a wooden stick. Tie these 2 paper cups to a wooden stick, and in the middle of the wooden stick you tie a thread so that you can hold this as a balance. Now what you do is, and see that the cups are tied in inverted position. Now after you set this, place a candle and lit it under one of this paper cup. Immediately you see that there is a slight disturbance in the balance, showing, you can see a slight disturbance in the balance like this. You see that, before you lit the candle, both the paper cups were on the same beam, right? And as you lit the candle and as heat is being produced, you see that one of the cup rises up. Why is this happening? Because the hot air which is present, it rises up and pushes the cup up, and this indicates that the air expands on heating. In the same way, whenever there is a fire, you see that smoke rises up. What does this indicate? See, when you heat something, the air becomes hotter and occupies more of space, due to which you see that the hot air which has become lighter will blow up. This is the principal technique behind this experiment, to help you understand that hot air rises up, due to which you see that the paper cup has rised up and there is an imbalance caused on the beam which you have prepared, right? And this hot air rises up, and always remember that hot air is always lighter than cold air. Hot or warm air is lighter than cold air. And see, this is nothing but convection, right? The hot air rises and the air from the surroundings is occupied. So this is a convection process which you have learned in chapter 4, heat. Hot or warm air is lighter than the cold air. So this process of like rising up of air can happen even in the nature, right? The warm air rises up, and at the same time you see that warm air at different places rises up, and at the same time you see that the cold air from different places occupies the space there, creating a low pressure. So these all things are seen usually in the nature also. Now let us learn how this rising of warm air will cause or will lead to different effects.